Connecting SOLIDWORKS to advanced simulations just got a lot easier with the 3D Experience platform. We have an existing simulation study to validate the crank components of this sewing machine. While a linear static analysis in SOLIDWORKS simulation provides good insight into the structural integrity, we need more capabilities provided by the 3D Experience platform to solve for the dynamic response from the inevitable needle break. Some of the sewing machine components are defined with custom materials and they need to be created in 3D Experience. To automate this task, we can import the custom SOLIDWORKS material library. This eliminates the need for the time-consuming and error-prone task of creating materials manually. In these new material objects, the SOLIDWORKS simulation material properties are maintained and converted to Abacus multi-physics properties. These are leveraged to solve for additional real-world phenomena. For the case of the needle break, we only need to add damage properties. Back in SOLIDWORKS, we have access to the centralized 3D Experience material library so we can ensure we are defining the correct materials. Additionally, when we transfer the simulation study to the platform, the materials along with the loads and boundary conditions are automatically mapped to the newly created structural simulation. With this, we can easily extend our simulation workflow. We can build on top of the simulation by adding a new procedure with an explicit dynamic step so we can solve for the needle break and the response in the sewing machine crank. To reduce the calculation time, we can run the simulation with the included cloud license. The simulation can be monitored from any device with a web browser, so we can easily track the convergence and see when the results are available. While viewing the results, we have identified an opportunity to optimize the shape and mass of the needle bar link. We can define the SOLIDWORKS dimensions of interest as parameters and select them in a new parametric design study in 3D Experience. With goals of minimizing mass and stress, the best design alternative is identified for us. With a couple of clicks, we can generate the alternative design so we can perform additional analysis and update the SOLIDWORKS assembly with the optimal part model. To evaluate how long the link will last, we can create a durability analysis case and define the fatigue loading. The results identify where and when the link will fail first. But how can we increase the life without changing the geometry? We can modify the surface finish in the weak areas only, which minimize the amount of manufacturing necessary to create a long-lasting part. All of our work is managed and automatically backed up on the 3D Experience platform. Furthermore, we don't need to spend time creating reports of our simulations. Since all of the data is on the platform, the details can be easily viewed in 3D in a web browser. Comments, notes, and changes can be shared with other stakeholders in the same cloud-based environment, streamlining communications throughout the organization. And this rapid product development and validation doesn't stop at structural analysis. We can take on fluids, plastics, electromagnetics and motion studies as well.